Given two independent random variables x and y uniformly distributed on the interval 0 to 1, compute the expected value of their minimum. That is, find the expected value of minimum of x and y. So we'll solve this question using two different methods. Let's go ahead and see how we solve this using the first method. Let's denote the minimum of x and y with z. Since x and y are independent and uniform on 0 and 1, the joint PDF is given by f of xy is equal to 1 for xy between 0 and 1. Now we want to find the expected value of z. Expected value of any function, let's say g x y, would be g of xy times f of xy dx dy integrated from 0 to 1 twice for x and y. Now in this case, f of xy is 1. As we see here, the joint PDF of x and y is 1. And this function g is the minimum. So this whole expression becomes this. Expected value of minimum of x and y is minimum of xy dx dy integrate from 0 to 1 for x as well as y. The next step that we need to do is split this integral into two regions. The first where x is less than equal to y and where x is greater than y. For x less than equal to y, the minimum would be x, and for x greater than y, the minimum would be y. So this is the part where x is less than equal to y, and this is where x is greater than y. Now for x less than y, we'll have the integral evaluated to x, and for greater than y, it's evaluated to y. The range would also change. So when x is less than y, we have the range from x is equal to 0 up till y, because we are saying that x is always less than y, less than at most equal to y. X will not exceed y. So the upper limit here, this can only go up to y. Similarly here, the range is, the lower limit of the range would be starting from x is equal to y and goes up to 1, because here x is greater than y. The limit on the uh, outer integral would be from y equal to 0 to 1, because this is not constrained here. So this is now an expression that we can now evaluate because we don't have functions in the integral. So now let's see how we evaluate this. The first integral is x dx integrated from x is equal to 0 till y. This gives us x squared by 2 integrated from 0 till y. Putting in the limits, we get y squared by 2. Integrating this again, we get y cubed by 3, and then putting in the limits, we get 1 by 6. The second integral is y dx from x equal to y till x equal to 1. So this y would come out of the integral, and we would just get x here when integrating 1. Putting in the limits for x, we would have 1 minus y, and 1 y from this, which was there initially. So this gives us y times 1 minus y. Opening the brackets, we have y minus y square, and then we integrate this part, y square by 2 and y cubed by 3. Putting in the limits, we get 1 by 6. Adding these together, we get the expected value of the minimum of x and y equal to 1 by 3. Another approach to solve this is using the CDF method, the cumulative distribution function. We start by assuming that minimum of x and y is denoted by z. The CDF, denoted by capital F, is the the probability that minimum of x and y is less than equal to some value z. Now, if the minimum of x and y is less than equal to z, it means at least one of x and y is less than equal to z, which means that we can write this as 1 minus the probability that both x and y are greater than z. So this is 1 minus probability that x greater than z and y greater than z. Now, if this is our distribution, uniform distribution between 0 and 1, and we take some point here, say z, what's the probability that x is greater than z, which means this, we are talking about this area, which is this length times this length. So of course, this length would be 1 minus z, and this is of course 1. The height is 1. So this area would be 1 minus z times 1, which is 1 minus z. Now, so probability that x is greater than z would be 1 minus z, and probability that y is greater than z would again be 1 minus z, and probability that both of these are greater than z together, we would have 1 minus z square. So we have this part here, 1 minus z square. Now we can differentiate this to get the PDF d by dz of f of z. This gives us 2 times 1 minus z. Now we have the PDF now. We can easily evaluate the expected value, which is z times f of z dz integrated over 0 to 1. This gives us z times this 2 times 1 minus z. 2 comes out of the integral. We have z minus z square dz. This gives us z square by 2 and z cube by 3. The constant part is outside. Putting in the limits, we get 2 times 1 by 2 minus 1 by 3, and this is equal to 1 by 3. So these are the two approaches to solve this question. This is a fairly simple and straightforward question. I hope you find this useful for your interview prep. Drop in the comments below if you have any other approach on how you would solve this, and if you'd like me to cover any other topic, whether it's quant finance, machine learning, data science, statistics, and so on. Thanks for watching. See you in the next video.